Okay, all right. So today's session is primarily going to be for the end term. So I'll just give an overview of the exam, the importance, how many questions will be there, and what are the important topics. Okay, so with the course, we've not really had any quizzes. So we are only be going to have an end term examination wherein all the questions will be objective in nature. So as in something computer based, so you can have either MCQs, MSQs or NATs. We are not going to go for a specific distribution between the three of them, but if you have numerical type questions, as in if it is something that is calculated and involves numbers, usually it is going to be NAT. And if it's theory based questions, you can expect it to come in the form of MCQs or MSQs. Coming to the weightage, it is equal weightage across all weeks. We'll go over the individual weeks in a bit, but it is equal weightage. No questions will be asked from week 11. And this is this is on transfer learning. So on this, we are not going to be having any questions. But apart from that, you can expect questions from every single week, all the way from week 1 to 12. Now, coming to the content that we have, week 1 firstly is Pandas and mainly about working with data frames. So, week 1 is about Pandas and data frames. So, mostly you can expect questions on these itself. Okay, so what are the things that you have seen when it comes to working with data frames? It could be either in your OPP or in your Kaggle assignments that you've done, or in assignments in general. What are different methods you have used when it came to data frames? Any answers? So what did you do when it came to working with data frames?
Locating rows and columns.
Yeah, so we had locating rows and columns. What else?
You need value in a specific column.
Okay, if I heard correctly, taking out specific columns. Is that what you said? Yeah, can you please repeat?
Like it was something like what are the unique value in a specific column?
Okay, yeah, unique values of a specific column.
Null values we are checking.
Null values of columns.
So that we can encode through numerical and categorical columns. We can encode.
Correct. Encoding through numerical, categorical. That was there.
Selection based on
selection based on conditions.
Duplicates.
Checking for duplicates. Anything else?
Conversion into data frames.
Okay, converting something to a data frame, converting maybe arrays to data frame. Okay, anything else?
Like what are the value in any specific row?
Okay, values in specific rows / columns.
Shape
Of the data set.
Column transformers and pipelines.
Okay, column transformers and pipelines will come to it. But in terms of week 1, can you? Sorry?
Applying functions.
Applying certain functions. Okay, I'm going to write it in brief. Applying certain functions. Okay. Anything else?
Filtering the data frame based on various criteria.
Yeah, so this I'll put selection / filtering here. Okay, maybe it's good to put it as something. Filtering the data frame based on certain conditions. Okay, anything else?
Showing descriptive statistics of a data.
Okay, showing descriptive statistics of a data set. Okay. Can you think of anything else?
Types of columns. Types
Okay,
of
data types of different columns. Okay, so I think this should more or less add some more uh, creating new rows and columns. And this is a bit sort of a repetition, but manipulating a data frame in general. Manipulating a data frame. So I can say create, delete, filter. So all these things will come into play.
So
So
what
with
about
regards, yeah.
what about outliers, sir? Outliers.
Yeah, there is the aspect of finding outliers using something like interquartile range.
Yeah.
But we are, at least from the point of view of the exam, we are not going to be asking you to find outliers as such.
Okay, sir. Yeah.
So coming to week one, as I mentioned, this is mostly about working with data frames and using different methods from Pandas, and some of them could even be NumPy-based methods. Now, locating rows and columns. So what are some functions you have learned for it?
iLock and lock.
Lock and iLock.
iLock and lock. So alternatively, we can even do something like df of column name, right? So this is, with this we can select certain things. For unique values,
df dot also. Df dot also.
correct, you can do df dot column name directly. This works when there is no space in between the column names as such. Okay.
Unique and unique.
Okay, we can go with unique and unique.
Value counts also.
Value counts.
Value counts.
Okay, all these things give us whatever we are looking for with that thing. Now null values.
Is an
Is null.
ENA dot sum.
Perfect. We
Is
have is
null.
NA is null, is NA dot sum.
so drop
Fill
NA.
NA. Fill NA.
Okay, then when it comes to null values, you have fill NA and you have drop NA.
Yeah.
Now these things, of course, you have to go and look at how the function is actually implemented. I'm just mentioning it briefly here. So for example, you want to do pandas fill NA. And once you go here, you can see that when the documentation opens, you will see that the method itself is fill NA with the brackets. This is how you call it. And within that, it might take in certain parameters. So for example, one of the important ones you would see is in place, whether you want to fill the values there itself or you want to create something new. And the other is access. So these are, and what value you want to fill it with. So these are some of the parameters the function takes. So whenever these functions come up, now for example, when it comes to unique and unique value counts, you don't really have to worry too much about what are the other things that you need to pass into it. But when it comes to these fill NA, drop NA, it is good to even have a look at it and understand how these things work, especially with things like access, filling the specific value and so on.
So we also have replace, sir.
Okay, we can add replace as well. So there is the method replace. And okay, so next we'll move to the next one, selection based on conditions. So what we mean with this is you can have a data frame and you might be given certain conditions. So now if I have, say, income data of a group of people. So you might be given the condition that the person has to be from a specific city and that his salary has to be greater than some specific value. So how would I do that? So say I have this right here. My column names are city and income. Okay, so and I want income greater than say 30,000 and the city as say something X for the time being. My data frame is called DF. Okay, so how would you sort of implement this?
So df of again a bracket. Yeah, df again df.
Okay, DF
Yeah.
again.
Df city
Okay,
equals to this something.
okay.
Equal to X.
Equal.
Okay, so
Equal.
it's a double equal to and
Double equal to.
And
It has
operator.
to be in bracket.
okay,
Yeah.
so
Uska
P,
and percent.
round
P,
brackets.
Oh, you want this to be in round brackets?
Yeah, yes, sir.
So
Yes.
Okay,
if we have multiple conditions, then we
Uh,
need to put it
and
into
operator.
brackets.
perfect.
Yeah.
Okay,
And
is it
operator.
this and?
No, that
No, ampersand.
Yeah, so it is the ampersand symbol. Okay, what else?
and.
DF
DF
dot
income.
income
Okay, so now I can do df dot income and
greater
greater
than
than
30,000.
30,000. Okay, so this is one of the ways with which we can filter things. So what we have done here is we have said that the first condition is I want the CD to be X, and then I want the income to be greater than 30,000. And then you pass in whatever rows satisfy these two conditions, you pass in the data frame.
Dot
Okay.
shape.
Now dot shape I can do to see how many rows and columns are there. But once you're given these conditions, you can be asked to do more tasks. One is on this specific subset, so to say. You might be asked to perform some other operation, either print a specific column, or again do another round of filtering. Maybe I can even do something like a new column. Maybe I want the person's age to be greater than some value. So when that is the case, you can pass in these conditions. Now only the rows that satisfy this are picked, and for that you want to print only the age column. So if you do just this, you're going to pass the entire. You're going to see the entire data frame. But if you want to see just one specific column, then you can pass in just the column name, or you can pass in groups of column names. So you have all those options, and if there's a condition, you can give that as well.
So we
Okay.
can assign to some other variable, and then that variable dot age equals greater than
That
age.
is also valid. So whatever values you get here, like
Huh.
what is being suggested is I can create a new df called df new equal to so and so, and then from df new, I can just print out the age. So this is also possible.
So syntax.
So
This syntax will change little bit, right? Like
yeah,
it
a
will.
little, you will have some differences in the sense this will just pass in the entire thing. All these spaces and all is not necessarily needed. I'm just giving you a rough idea of the type of questions that you can expect. So I
Okay.
can say you're given this data frame. Now you first filter based on these two conditions, and then on top of that you do something else. So this way you're going to be given some code snippets, and you would need to know how these things are done.
Yes.
Okay, so for selection based on conditions and filtering the data frame based on conditions, you can expect questions such as this. Okay, so we saw the syntax. You first write data frame. If you have a condition based on specific column, you write the condition. You have to put them in round brackets. You also want to make use of ampersand to connect two different conditions, and then you will get your data frame satisfying those given conditions. Okay, so now there are these other things as well. So I'm going to focus on a few of them. One is, say, showing descriptive statistics. So when it comes to descriptive statistics, what are the things that you see when you do df.describe? So describe is the method for it. But what are the things that you would see?
Mean, median, quartiles,
Yeah, you will see mean, median, quantiles. You see standard
maximum
deviation,
and minimum, maximum and minimum.
maximum,
10%,
minimum.
25%, 50%.
Correct. You'll see the different quantiles, and you will also see minimum, maximum, the count, and so on. Now, you will also have to know how to get these values individually. So if you were asked what is the mean of something, then you know that the function is actually simply just dot mean and then brackets. So this way you might be asked individual sort of statistics in that as well. Okay. Overall, I would say in this, these are what we usually apply with. These are the functions that we usually apply on data frames. But you should definitely be comfortable with this. You have to be comfortable with dealing with null values, selection and filtering based on certain conditions, maybe with cert, how to get descriptive statistics based on whatever is asked, either it is mean or median or so on, and then creating new rows and columns. So mostly I would say these are the important parts that you have to be very thorough with when it comes to week one. So if you've done enough of your assignments and of course if you've practiced well for the OPP, these things should be quite straightforward. And as I mentioned, with these things also do ensure that you once go to the documentation and see if there is anything you are unfamiliar with and do that. Okay?
Excuse me, sir.
Yeah.
So just want to ask one thing, like in the PYQs, we have like trees and lots questions are from those sides, trees and classifiers. So these questions I'm not like I'm seeing in PYQs. This null
Based on Pandas data frame?
no, based on PYQs. Previous end terms.
Are you saying you've not seen questions such as this in the previous papers?
Yeah. So
for
I'm
one,
more concerned about those questions because I'm not. I don't have any idea like how to solve those questions. Like it's all going over there. Yeah.
Yeah. So for one, today I'll just give a brief of all the weeks on what are the things that you need to focus on.
Yeah.
And we are having another session tomorrow. We will keep it exclusively for clearing any doubts that you have. So whatever questions you've gone through, if you have any specific question, then of course you can also post it on Discourse. If not, tomorrow we'll keep it entirely for clearing doubts. Okay. But then I will reiterate, for the end term, it is equal weightage across all weeks. And even if you have not seen it in the previous term papers, you can take the previous term papers to understand what kind of questions might have been asked. But there can also be a lot more newer type of questions. So from week 1, you can definitely expect questions based on this type, based on manipulating data frames.
Okay, sir.
Okay. All right. So moving on. So next we'll go to week 2. So week 2, and I'm going to combine both week 2 and 3 for this. Okay. So with week 2 and 3, we have mostly introduction to an Scikit-learn documentation. So to start off, you would have been given an intro of what Scikit-learn is and so on. You'll have some questions related to the API. Then there is data loading demonstration. So some of the important parts, for example, in Scikit-learn are these estimators or transformers. So what are these? Anything that you use to modify your data set. It could be either through scaling, encoding, missing values, and so on. All these things are coming under either estimators or under transformers broadly. And then fit transform is one of the important methods that we use. Fit primarily for learning and transform to actually do the transformation. So this way, even though these activity questions you might have done previously, it might be a good sort of exercise to revisit all these simple questions to answer the theory part. So along with that, we did a few things. We went to data pre-processing. In data pre-processing, you will have things like imputing, you will have things like encoding, you will have different ways to convert your data from one form to the other such that it is ready for model training. Then we have a video on handling missing data. This will cover the different ways to handle missing data. It could either be through dropping them or through imputing them. And in terms of imputation as well, you would have again seen something like a simple imputer and a KNN imputer. Then what do you do with categorical data? You want to encode them. There are again different ways to encode. You would have either ordinal or one hot as the primary ones that you would have seen. There's also label encoder and so on. And then we can also choose to combine all these things. So with that, we have scaling methods, we have filtering based on certain conditions. You would have seen RFE, SFE, and so on. But more importantly, then when you come to week 3, you will have seen combining all these things. You will have seen chaining transformers, either through use of pipelines or using something like column transformer. You are going to be combining different things. So if I were to summarize what you see in this particular week, it will be sort of functioning as an introduction to Scikit-learn, and then you will see some pre-processing techniques. Then you would have seen things like PCA, feature selection, and then one important part is use of pipelines and transformers. Okay, something like transform versus fit transform is something you would have come across. So you want to learn only from the training data, and then transformation you want to do it on both the parts of the data. Then you would have had things like feature union and say variance threshold. Yes.
Yeah, sir. In column transformer, we are using pass-through, right? Something pass-through or in the last.
Yeah, there is pass-through. That is when you want to see with column transformer, you are going to modify certain columns only.
Okay.
And what do you want to do with the columns for which you are not performing any transformation? So that is why you do remainder equal to pass-through.
Okay, so in ChatGPT and all, I asked, so they never use pass-through. They use some other syntax, like they never use pass-through, and still I'm getting the same results. Like.
Yeah. So see, the logic behind it is, for one, what do you know what happens when we do not use pass-through?
No, sir.
Yeah, so what you're doing there is you're modifying certain columns and you're saying you want to keep the remaining columns, but you
Yeah.
don't want to make any change to it.
Yeah.
Now, if you do not give that remainder equal to pass through, then it might even end up dropping all those columns on which it does not do any transformation. That is why we say you keep the remainder, but you just pass through it. You don't want to do anything to it.
Okay. So the ChatGPT using little bit different syntax. Maybe the syntax has been changed. I think I don't know exactly, but to be honest.
Yeah, see, for one, of course, you have to be very clear on what that code snippet is doing and what it ends up retaining. Like, for example, if you see this, remainder equal to drop is given. So whatever code snippet you might have seen, either it might have done the case where all the columns have been mentioned in the beginning itself. So you can pass in a list of transformers here. You can say what are the different things you want to do. For example,
yeah, it using column transformer, then transformers equals to this. That's it.
Correct. It will use transformers equal to something. I'm saying there it might mention all the column names. So if it were to do that, then all the columns will anyway, it will have seen. So it is not going to drop any. But if it has modified only certain columns, then it is going to end up dropping the rest. Maybe subsequently you had no need for those columns that were dropped. So in that case also, again, it is okay.
Okay. Even in OPP, I use the same sort. That's
yeah. So if you've got the correct answer, then it is fine. But again, as I said, you have to be very clear on how it works. So if you see here, so this is where we have used column transformer. We have passed a list of transformers, and here you can see certain column names are given. Now, if all the column names are given, then fair enough. Once you do your fit transform, all those columns will be kept. But if you don't do that, then your remainder by default is set to drop. So which means it is going to drop the columns that it has not seen. So you can see by default only the specified columns in transformers are transformed and combined in the output, and the non-specified columns are dropped. Which is why you want to give and pass through if you want to retain those other columns. Okay, so it is going to be very much dependent on the specific code snippet, whatever it is doing. So it is good if you learn how it actually works, and then you can choose to compare. Because we saw, right, even with these other things, there are different approaches to get to the same thing.
Okay. And sir, we have a sparse output equals to true and false in one hot encode or something, right? So what happens in true and like in true, we drop 0, right? Or like.
Yeah, so it has to do with how you are going to end up storing the values. So what happens with one hot encoding is only for the value where it is present, it will be 1, rest of the values will be 0 in that column. Okay. So if I had a column taking, say, multiple, maybe apple, banana, and some orange or something, it will create new columns for apple, new column for banana, new column for orange. Wherever apple is present, it will mark 1 and the rest as 0. So now this format can end up having a lot of values being 0, and this is called as a sparse representation. So when it comes to sparse output being true or false, it mostly has to do with how you want to end up storing it.
So if sparse output equals to false, then it will not store 0, right?
If it is called as a CSR, it goes to compress sparse row, it ends up using a different kind of storing for it. Okay. Yeah, this is end term, but there is going to be, of course, some overlap in the code snippets. So the reason I went to is in week 2 you are going to be covering pipelines and column transformers, and specifically when it comes to these things, you want to go to the documentation once, see what are the different sort of parameters it takes in. And you might be given different code snippets, and you might have to identify what is the correct way to actually build it. So maybe an example question could be exactly what you saw in the OPP. So you might be told you have so many columns, you want to use simple imputer on this column, you want to use simple imputer with a different strategy on another column, and how do you implement it? So in that case, you would want to, if you've not known, you want to go to the documentation here. You can see an example. So you can take in the column transformer, pass in the different transformer objects, pass in either the numbers of the columns or the column names, and then you do your fit transform. Likewise, the other important part in week 2 is definitely, say, pipeline. So for this also, you can go to the documentation, see the different settings it gives. So with pipeline, again, you have different ways to do it. You have steps. So how do we do the steps? We have seen it previously as well. So once you have the pipeline, you're going to write things in brackets. Yeah, is there a question?
Sir, during the exam and the questions, will we get any reference document for seeing the parameters, or if we want to have a look at the values or the text.
No, you will not be getting any documentation or any extra information. So mostly it will be a bit straightforward in the sense you will know like some obvious error. Like for example, if I'm going to build a pipeline, you know that you first want to have a square bracket, and within that, in round brackets, you write your different methods. Like for example, I want to call this as imputer 1, and then you'll call simple imputer here, and so on. So you're going to you're going to follow a particular pattern with which you're going to be doing this. So this might be my second object. Maybe I want to do encoding here, so I can call it encoder 1 or so, and then again call the encoder object and so on. Now here in these cases, there would be some obvious errors. Either there will be a different syntax error, or maybe within simple imputer, I will have a numerical column, or maybe I'll have a categorical column, but I'll have the strategy as V. Now these and all are obviously going to be throwing errors, right? So if you've done your bit when it comes to practicing these things, coding these things live, then you will know how to write these different things. So that way you can catch in whatever errors are there and whatever is the correct implementation of it. Other than that, I would recommend going through the documentation. For the most part, most of the parameters you see are going to be very familiar to you. But if there are ones that you are not familiar with, it's a good idea to once go through it and ensure you have some idea about all of it. Now, for example, if I were to take pipeline, so it takes in a few things. The first one is steps wherein you want to pass in different estimators that you want to run in sequential order. So the first one takes that. The next one is, do you want this to be transformed? So this enables you to call in things with different names. So if you want to take in certain parts, you can do that with this. Then there is caching. So you can do that using this memory parameter. And finally, one of them is verbose, which you would have again seen in some other methods as well. This is if you want anything to be printed while the fitting or training is going on. So this varies. So if you do it in say grid search CV, you can give it different numbers, and here it's just a true or false. The other thing you would have seen is the attributes. Once you finish training, how do you access different elements in it? So this is the first one is given as named steps. This is basically whatever name you've given, you can pass it after it is fit. So if I had a pipeline object as say some pipe, and then here I can pass in whatever I had given as a name. So this way you can call in the named objects, and these are roughly the kind of questions you can expect. So in terms of pre-processing techniques, you will have imputation, you will have encoding, and then you can even have things like PCA and feature selection, but you will be given different combinations to implement. So whatever questions you've seen in the OPP, questions similar to that will be given, but this time we'll also give you the code snippet, and you just would have to identify which is the appropriate one. Is that okay?
So, sir, apart from the question, any other information which is required to solve that question will be given, or we have to assume, or we have to memorize certain things?
For most of the questions, you will not need to memorize anything, but there will be certain definitely like obvious things that you would need to know. It will be once if you've done enough practice. Like for example, in some places fit transform might be used, some places just transform might be used. So identifying which one is better, which one is more appropriate one might be something that is not explicitly stated. Okay, the other is, okay, maybe a better example is, let's take some model. Let's maybe take SGD regressor. Okay, so here you will have certain parameters. Like for example, you take the loss function. So when you're going to be using a regression model, only certain kind of loss functions are allowed. You will not be required to know exactly which loss functions and so on, but you should know that if you were to use a classification related loss, it is clearly incorrect. And maybe it will be mentioned, I want to use say L1 or L2 regularization. In that case, you should know that the parameter that you need to modify is the penalty parameter. The other example could be wherein you have max iter. You can see it has to be given as a number, but maybe it is passed as a string. So this way you will have some variations. Okay. Coming to memorizing now, all these methods that you see, if I were to open this list, you will have all these models. So from linear regression all the way until in the end, you're going to have neural network, MLP regressor and MLP classifier, I would say you have to once go through the documentation of each of these methods. So the variants in question will mostly be like that, like how I mentioned here. The question might say you want to implement an SGD regressor where the initial learning rate is set as some 0.0 something, where the loss function you have to use is say some Huber loss, and you want to use say L1 regularization. Something like this will be given to you, and that way you have to know which are the parameters that you need to change here. Is that okay?
So how we define learning rate in the SGD regressor?
Here, learning rate in terms of whatever other variant we take. For example, this one, something like this would be given.
So we
which
take
one you want, and the
ETA?
initial one is with ETA 0.
Sorry, can you repeat?
Yeah, the initial learning rate is with ETA 0. And the way you want to modify learning rate can be modified with this one. Like for example, if you go to this, you will have different versions. Like for example, constant, which is you want to keep whatever initial learning rate is there, you want to keep that only all the way till the end. The other is you want to use either optimal, imp scaling, or adaptive. So in these ones, the learning rate keeps changing as your model is being trained. Okay, so you can expect questions on this. So on which parameters, like what are the values you have to take based on the condition specified in the question. Okay.
So what is alpha then?
Alpha is for regularization. So you can read this here. So this is the constant that multiplies with the regularization term. Whereas first with penalty, you can set either L1, L2 or elastic net. That is if you want regularization. Now one of them, L1 is for lasso, L2 is for ridge, and elastic net is if you want to be there in between. You want to take in both of them. So now here you can set the L1 ratio. This happens when you use elastic net. So where you can see the values mentioned here. If you take L1 ratio as 0, then it becomes L2 regularization. Whereas if you take L1 ratio as 1, it becomes L1 regularization. And if you want a value in between, you can pass that as well. And now alpha is the term that you multiply to it.
If we change the alpha value, like if we increase or decrease, then the it will result in underfitting or overfitting.
Yeah, so these are the cases you would want to learn also. Now, if you were to have higher regularization, then the tendency is that your model will overfit. And whereas if you have lower regularization, then your model can underfit. Okay.
Okay, sir.
All right. So with all these functions, so this is what we primarily have in week 4. We can even go to week 4 now. So if I were to mention the things in week 4, okay, to start off, we have all the models that are covered in this week itself. And then you have things like hyperparametric tuning, and then you have regularization, cross-validation. Okay, so this is mostly the important parts from week 4, I would say. And there's going to be a lot. So when it comes to this, now how do I put regularization is one of the questions. So if you are given a SGD regressor model and asked to have ridge regression on it, what are the parameters you have to change? The other is maybe you are asked a condition on you want to stop the model training if the loss function does not decrease. In that case, do you know what parameter you have to change?
N iter to change.
N iter no change is a different one.
Tolerance.
In terms of loss
Tolerance.
function, yeah, so you have tolerance as one of them. So this is for the stopping criterion. So whenever your loss does not change, it is tied to N iter no change. Okay, so that is one thing. The other one that you have here is early stopping. So this will also do when you have sort of a validation score with which it keeps checking. And if the score does not improve, then it can again stop the model training.
Yeah. Sir, can you please again tell the difference between tolerance and N iter no change?
Okay, so tolerance is the stopping criterion, the initial one. It says if you're, see, it is described here, you're going to have 1 as your loss and the other is your best loss. So when you're training multiple models, each model is going to give one loss value. Is that right?
Yes, sir.
So in this, we can think of it as multiple epochs. So you're going to train the model once on one part of the data set. Then again, you're going to do next iteration and so on. You're going to keep training and checking the loss in each iteration. So now if you end up getting a loss such that it is loss plus tolerance is greater than the best loss. That is, you had a good model, but then your loss kept increasing. Okay, and it crossed a particular threshold, then you want to stop model training. Does that make sense?
Oh, you mean
let's-
to say it is like threshold tolerance means?
Yeah, you can think of it like that. So first iteration, maybe I had some 0.5 as my loss. Second iteration, it reduced to say 0.49. Third iteration, it went to say 0.48. Fourth iteration, it again started to increase. It went to 0.5 again. So now here clearly you know that this was the best loss that you got. And now if it is more than the threshold, if you do best loss minus threshold, and if the loss is still greater than that, now if your tolerance was say 0.01, okay, so 0.48 plus 0.01, I would have 0.49, which means you are okay with the loss going to 0.49, but now the loss is even greater than that. It has gone to 0.5, which means it has breached the tolerance that we had. So which means we want our model training to stop. Is that okay? And now n iter no change specifically, it tells if this happens for how many consecutive iterations. So n iter no change is here. So yeah, so here if it happens, by default it is 5. Now for 5 iterations, if you do not see the loss improving, that is the loss reducing, then you want to stop it. Is that okay?
Yeah, so in the example you have shown, we're gonna do iteration for some more times, right? In that the same
Correct. So you can have it run for a few more iterations.
Okay, thank you very much, sir.
Yeah. So with regards to week 4, now you have all these models, right? So for each model, I would say you once open the documentation and then go through it. Like for example, let's do one more. So in terms of support vector classifier, maybe it says the regularization parameter should be set to say 2. The kernel that should be used is say linear, and maybe their degree is mentioned. Degree is 3. So if you've done enough, you will know that degree makes no sense for a linear kernel. It only makes sense for polynomial kernel. I'm not saying this is the exact kind of questions that will come, but it is important that you go through all these models once, see all the parameters that it takes, and have a rough understanding of how these things work. And now here we are not expecting you to know every single thing. Like break ties is not, you would not be asked a very specific question on say break ties, but you could still be asked on what are the values say the kernel can take. You might be given a few options and you might have to select the valid options from that. Okay. And there's also something like class weight. So now what does class weight do? This is mainly useful when you have some imbalance in your data set. So by default it is none, but if you set to balance, then it is going to take the proportion of how much data points are present in each classes, and based on that it is going to do the model training. So this way with each of these models, you once go through the documentation, see the attributes and the parameters, and be familiar with what they do broadly. Okay, then you have something like hyperparametric tuning. So in hyperparametric tuning, you would have seen at least a couple of methods. So one is grid search CV and another is randomized search CV. So when it comes to grid search CV, what are the different parameters? Do you recollect? What are the different parameters that you pass in?
Like max
The,
depth.
the estimator, then the grade,
Correct.
cross validation, and
CV.
the error we want to use, the scoring we want to use to
Right. So
do
here
the
again, yeah. So the important ones are like you mentioned. You have estimator, param grid, scoring, then refit, cross validation. Yeah, this is and verbose sometimes, but these are mostly your important ones. and even n jobs. N jobs if you want to do it in parallel. Now, with this, the estimator is whatever model on which you want to do your training, or you want to try out different combinations. So this is your estimator. Here you can pass in decision tree, k-neighbors method, support vector machines. So whatever it is that goes in here, the corresponding parameter grid goes here. So you can even have a combination. You might have some, say, PCA plus some model training, and that in the parameter grid you can pass in all the different parameters. Now, if it is decision tree, what are some parameters? Does anyone recollect parameters for decision tree?
Max
Min,
depth.
max depth, min leaf, minimum samples
Max
for the leaf.
underscore samples.
Correct. So you have min sample sleeve, min sample split, you have max depth, you have CCP value. So this way you're going to have many different parameters for it, and you can pass in those different combinations in parameter grid. And what does scoring stand for?
The scoring which you are using for the grid search.
Yeah, so this
It can be
is
negative.
Accuracy, or it can be
Normally it is for regression
Negative
it is
mean
R2.
square. Negative mean square error something.
For
right.
regression
So,
it is
yeah,
R2,
simply
and
put,
for classification it is accuracy.
right. So simply put, this is going to be your evaluation metrics. Okay. So here you will have to know now what are the sensible evaluation metrics. So you would not use a regression related evaluation metric for a classification problem. And if you have an imbalanced data set, what is the evaluation metric you are going to use there? So that way that is going to be important here. And then this is corresponding to week 4. Broadly, strictly speaking, this is weeks 4 to 6, because in week 4 you have the theory of all models, and in week 5 we've implemented regression models. Week 6 we've implemented classification models. So for all these models, any topics that you see here, I would say simply put, go see the title, and if you don't know what is regularization, go and see what regularization is. Hyperparametric tuning, you will have seen grid search and randomized search CV, see how those things work. Okay, so this way you individually go to the documentation and roughly read through this. This is how I would recommend doing the preparation. And if you've done your Kaggle assignments as well as the OPPs, it will mostly be the straightforward stuff. So now when I pass in different parameter combinations and different values of cross validation, how many models do I end up training? So this is one sort of possible question. Okay, is that fine? All right.
So in that, sir, there is a variation, like how many unique trees you are training, and actual how many models you train. So there was means if you multiply by the cross validation, you will get the
correct. So this is the number of models that have been fit, and the other could be the number of different estimator combinations. So if you see how many different models you had, it only depends on parameter grid.
yes.
Okay, to just confirm the question that he was saying. Now maybe I'm training my estimator equal to decision tree classifier, and for the param grid for it, it has to come as a dictionary. Since I'm not using a environment for it, it might look a bit off, but yeah. So max depth, and then maybe I give 2, 4, 6. Okay, and then we'll do one more. We'll do say min sample split, and again for this I'll do a 2, 4, 6. Okay, so this is my parameter grid, but then cross validation equal to, say I have 5. Now if you ask how many different decision tree classifiers combinations are present, what is the answer for that? Okay, that is how many models have been trained. Now in terms
9.
of combinations,
CV into
9.
yeah, you are going to have 9, 3 into 3. So you
So
can have
unique models that we have, right? This is the
correct. So
unique.
this is the
Sir,
different
how
unique combinations that you can have.
now we are getting 9, sir?
Yeah, so I'm just writing it.
So how it
Okay.
will be asked in the examination to differentiate? Suppose
No, it
answer
will
is
be
40.
quite, yeah. So see, if I were to ask you how many different model combinations are present, then it is just 3 into 3, 9. So when max depth is 2, minimum sample split can be either 2, 4 or 6. Likewise, when max depth is 4, it can be 2, 4 or 6. And when max depth is 6, it can be 2, 4 or 6. That way there are a total of 9 possible combinations. So the number of unique combination of models that you'll get is 9. But when it comes to how many models are actually being trained, since we are using cross validation and 5-fold cross validation, we are going to have 9 into 5, 45 models being trained. Is that okay?
Okay. Okay.
Yeah. So in the exam, it is going to be straightforward. Like for example, we might ask how many times has the model been, how many different models have been trained? What would be your answer for that?
45.
Yeah, then it is 45 because 45 times decision tree classifier dot fit will end up happening. Okay.
Okay.
So 45, how you are getting so?
Yeah, so firstly, there are 9 different combinations. Now say this is combination 1. Are you clear with how we got 9 combinations?
3 square. I mean,
Yeah, so you have max depth as taking values 2, 4, 6, right? So let's actually just do it. It's time.
So it's max depth into min split, right? All the
Yeah,
combinations.
correct. Okay, so I have 9 combinations. And because I want to check when max depth is 2, max depth is 4, max depth is 6. So you will have, and when max depth is 2, 4, 6, your minimum sample split also you want to try when it is 2, 4, 6. So first minimum sample split is 2, then it is 4, then it is 6. Yes, is there a question?
Sir, here max depth 2 means its value 2, or is it indexing of 0, 1, 2?
No, this is that you want the depth to be 2.
Oh,
Value.
it is the value.
Yeah,
Yeah.
it is the value.
Okay, thank you.
Okay, you mentioned that. No, it is the value.
So how many models are trained? That answer is 45. What if
Correct.
you want to ask the 9, the answer to be 9? What will you ask in that case?
It could be something like how many unique combinations of models are possible.
Okay, how many unique combination of models? Okay.
Yeah, you don't have to worry about the language. Mostly it will be straightforward. So if it says trained, you want to include all of them. You want to include the cross validation as well. Okay, so here are the 9 combinations. Okay, firstly.
And sir,
Okay.
for 45,
yes, sir.
what question it can ask?
45,
Yeah.
what is that,
So
sir?
yeah. So now we have cross validation. Okay, cross validation is 5. So what does this mean? What does cross validation mean?
So one test and rest training.
Correct. So if I have my training data of say 1,000 samples, what will a 5-fold cross validation do?
800 training and 200 test, like that, 5 combinations of that.
Okay. So is that okay with everybody? So maybe I can first break it into 5 folds of 200 plus 200 plus 200 plus 200 plus 200. So this way, this totals 1,000 points. So first I'm going to use these 4 for training and this for test. The next time I do, I might use these 3 and this guy for training and just this one for test. In the third iteration, I will use these many for training, this guy for test. In the fourth one, this one will be test, and in the fifth one, this one will be test. So this way, 5 different models are being trained. Is that okay? And I'm doing 5-fold cross validation because your combinations are the same. The the parameters you're testing for are the same, but then the data set you're using is different because different samples are now being a part of your training set. That is why 5 different model fit or model training has been happening with 5-fold cross
For each
validation
combination. For each
for each
combination.
combination. So this is why you will have 9 into 5, 45 different models being trained. Is that okay?
Yes.
All right. Okay, just give me 1 second. Okay, all right. So that is the part about hyperparametric tuning. And as I mentioned, for model building, do go through all of them. Like for example, we've done our sessions on boosting models, voting, random forest, and so on. Know the parameters of these different models. Okay. Week 5 has the actual regression implementation of each one. We will take one example for this as well.
So, sir, again, I repeat, if the word training is used, then you have to multiply the combinations with the CV, right?
Yes, yes.
And if the word combination is used, then you have to just give the number of different
Okay, so
decision trees.
let's do it this way. What do you use to train a model? What is the method that we use for training a model?
Fit.
Okay, so we have maybe what decision grid search dot fit, and we have xtrain comma ytrain. Yeah, we use decision tree itself. So when we say how many models have been trained, it simply translates to how many times fit has been called.
Fit is
And if
used,
you're doing
yes.
5-fold cross validation with 9 combinations, then you will have 5 into 9, 45 different times that fit is called. So 45 different models have been trained. Is that okay?
Yes, sir.
All right. So then we have, say, k neighbors regressor. We'll go to this. So here, once again, you'll have things like number of neighbors is one of the important parameters, so to say. And then you have the p-value and metric. So p-value is, do you know what p-value is?
Yes, sir. It can be if Minkowski's metric is there, then P1 stands for Manhattan and 2 stands for Euclidean.
Correct. So this p-value is called as the power parameter, and when p is 1, it is Manhattan, and when p is 2, it is Euclidean. So you don't have to know all these things very much in detail, just some surface level things like this. You simply put, you go to the documentation, see the default parameters, and just see what they mean. Okay. So that is one thing. We'll do random forest classifier as well. So random forest classifier is again going to have different parameters with itself as well. So one of the things is, okay, what does n estimator stand for? Very simple, straightforward one.
The number of estimators we use to train the random forest classifier.
Correct. So this is how many decision tree models we'll have.
Yes, decision
right?
trees, yes. For
Okay.
decision trees, or yes, for random forest, we only use decision tree only, yes.
Correct. And then what is criterion?
The method we use to calculate the
Entropy.
Correct. So it is something like that. So entropy is an option. Instead of having criterion as Gini, you can have either
impurity
entropy
to calculate the impurity.
1 minus probability of this and probability minus probability of that.
Yeah. So that is one way to, that is what we define as impurity. So criterion is what we are going to make use of to see how good sort of our split is in some sense. So it can either be Gini, or it can be entropy, or it can be log loss. Okay, so you can see that here. So these are the ones that we use when it comes to random forest classifier. So similarly, regressor has different ones. So that is your criterion. What is max depth? So these are mostly self-explanatory, but you have max depth, which is what is the depth of the tree that you want. Minimum sample split. This is how many samples should I have if I want to make a split? That is, we know that we ask questions and make the split, right? So what is the minimum number of samples that needs to be there? And what is the minimum number of samples we need to call something a leaf node? By default, it is 1. But if you set it as 10, then it says that only if there are 10 points am I going to call it a leaf node. If not, I'm going to continue splitting. And if it has, so that way it will not go lesser than that. So this is the minimum number of samples that need to be there if you want to call it a leaf node. Then some other ones in this could
So
be,
these parameters gonna change max depth, right? Max min sample split, min sample leaf, they're gonna change max depth, right?
they can influence it. That depends on case to case basis. Now, for example, say your data set had 10 points and we are going to say min sample split itself has 20. That means you're not going to have any split happening at all. Your max depth is going to be 0. It's just going to be just one basic root node. Okay.
Okay, sir.
Yeah. So that way these things can influence it a bit. Other than that, yeah.
Even root node can have like max depth equals 1 or it will be 0.
By default, I am not sure. You have to just
It's
check
1.
it once. So if I remember correctly, I think for just the root node it is 1, and then it goes on as 2, 3, 4, and so on. You can
Okay,
just
sir.
verify it by building a simple model. Okay, then you have max features. This is how many you want to retain. Square root is the default, which is how many features you want to consider while you make a split. So these are different options. This is because in random forest, when you build, you're going to be building 100 different estimators, right? And within that, within each of them, you're going to be making a split. And when you make a split, how many of the features in your data set do you want to consider at once? So by considering lesser number of features in one go, we can help our model generalize better, not be reliant on a specific feature. Okay, so this is the use of that. So this way for each model, you're going to have different parameters, and depending on the values of those parameters, your models will function differently. Okay. So weeks 4 to 6 mostly tends to cover just that. So here, not mentioned, let me add it. Yeah, so for week 4, these are the things you want to focus on. Go through the documentation of all of them, know how to add certain conditions. Like if you're asked to train a model with some, say, specific conditions, like add this regularization, have this as the learning rate, then this is what you would, this is what is important from this week. And then with cross-validation, you might have a couple of different methods. You have either, say, k-fold cross-validation, or you want to do leave one out cross-validation. Then you would also have something like the shuffle split that is there. So have a rough idea of how all these things work. Okay, weeks 4 to 6 covers mostly that. And week 7 is the evaluation metrics. So week 7. Learn about all evaluation metrics. So when I say all, like I don't mean every obscure one. Can you name a few common ones?
For regression, it is R2.
Okay.
MAC R2 and others.
So accuracy score.
Okay.
Accuracy is for classification.
Yeah, so that is also evaluation metrics itself.
So precision scores.
Correct.
Precision, F1,
recall,
F1 score, recall.
F1. Okay.
Classification report.
Classification
MLP.
report is not an evaluation metric, but still it is important to know how classification report works. So you have classification. Other things in this week are classification report, confusion matrix.
Confusion matrix.
Okay. So mostly learn about these things. I would just say that you don't need to go much beyond this. Learn how to read a classification report, how to read and create confusion matrix, and how to calculate all these things. Like what is, if you are given a simple calculation, you should know how to do it.
So we also have direct score, right? Just the score.
The score that you get is R2 score for regression and accuracy for classification. So what you're referring to as, once you finish model training, say I had linear regression as LR. So what you do is LR.score and then you pass in your X test, Y test. This is actually R2 score in the case of regression and accuracy in the case of classification. So it is not a separate evaluation method.
Okay.
Okay. Yeah, but coming to week 7, know how all these things work. Is there anybody who does not know how to read a confusion matrix or classification report?
So classification report, I don't remember the format actually.
Okay, not as a formula. So classification report, in its output, it is going to give you the values of precision, recall, F1 score, accuracy, and in the end, you are going to see how many samples are present as well. Let me just navigate to that. So this is the code snippet for it, classification report, and then you want to pass in the true and the predicted value. And this is the output, what you see here. So it gives the precision, recall, F1 score for each of the classes. It gives the accuracy score, and it gives something called as macro average and weighted average, which has to do with how you combine these things. And you have support. Support is number of points. So one here says there is 1 point corresponding to class 0, and there are 3 points corresponding to class 2. You can see that here as well. There is 1 point each for 0 and 1, and 3 points corresponding to class 2. So that is support.
What is support, sir?
Support is how many samples were there in your true labels.
Okay.
Now, why true is your true label, and in this particular list, why true? Maybe I can zoom in a bit. Yeah, you can see there is 1 sample corresponding to class 0. That is why in this row at the end you have 1, and 1 sample corresponding to class 1, and 3 samples corresponding to class 2. You can see that here. Okay, so that is support. Okay, and here there's also.
Sir, how we are getting 3 samples for class 2?
You can see this list, right?
So for y true, we are considering the support, right?
Y true. There are 3 values. 2 appears 3 times.
Okay.
All right. So that is classification report. Now confusion matrix, you have it for 2 classes, or you can have it for multi-class. You should be able to calculate for both those cases. That is things like accuracy, precision, recall, and F1 score. Okay.
So it will always be starting from 0, 1, right? Y-axis is 0, 1 and x-axis is also 0, 1. 0 means
that will be mentioned. So you will be given the classes. Either it can be class 1, class 2, class 3, class 0, class 1, class 2, or it can even be class A, class B, class C. So there is no restriction on that, but it will be mentioned in the question.
Okay.
Okay, so that is week 7. In the case of week 8, we have NLP and image.
So this is a new topic, right?
Yeah, so for this, I doubt you will see any questions in the previous papers, but no, you will not have any questions on large-scale learning. But on these new topics, definitely there will be questions, and minimum requirement, I would say, is watch the videos. You will not get any questions that are too complicated or out of this, but primarily you just need to watch the videos for these two, and ensure you do the assignments as well. Now this is true for these new weeks. So week 8, and then you have week 9 is an old one. Then you have week 10 with recommendation systems, and week 12 with time series. For these 3 weeks, I repeat, week 8, week 10, and week 12. For these 3 weeks, make sure you watch the videos at least once for the 3 weeks. The questions will not be outside that. Other than that, doing the assignment wherever it is there, you should be able to do a smaller scale version of that through hand calculation. So that is the only requirement. Okay, so here you have, yeah, is there a question?
Sir, can you please repeat what did you just said? Week 8, week 10, and
okay,
week 9.
I'll just come to it. So week 8 is on NLP plus image. And you have week 10 on recommendation systems. And time series. Okay, so these 3 weeks, for all of them, you just have to watch the videos once. The questions will more or less come from those. And for week 8 and 10, do the assignment assignments also. So assignments, simpler version of that, you can be asked questions.
So week 9.
Week 9 already, it's not new content. That is why I have not mentioned here. Week 9 also you'll get questions. Week 9 has things like hierarchical clustering and k-means that are important. You can expect questions from that. But for that, you would have seen questions previously. Like in the previous year papers, you might find questions. So that is why I've not mentioned that yet.
So will there be a mock containing the questions from these new weeks?
That might not be there. So
Why, sir?
Sorry?
Why mock will not be there?
We will release a mock tomorrow, possibly tomorrow. And in that, you're going to have questions on the other weeks. You will definitely have questions. So it is mostly from the previous terms. Whereas for the new weeks, for now, I would suggest that you primarily focus on watching the videos once and also doing the assignments, understanding the ideas that are there in the assignments. Now, even if we were to give questions, the questions will be very, very different than what we would give in the mock, because the mock is only an indicator of the level of questions on some level and sort of how many questions can be there and to get you into that exam practice setup. But the questions themselves are going to be very different. That is why I'm saying, if you want practice, just do the assignment, whatever topics are there in the assignment. How many of you here have done the week 10 assignment? Okay, if you can just tell me what were the topics involved in week 10 assignment, whoever has done.
Popularity based recommendation.
Okay.
Then
Collaborative.
And before that there was this one more type was there, forgot.
Yeah, so you'll have had a content based and collaborative.
Content based, yes.
Okay, so these were the topics, but then coming to the assignments, you would have had to use specific methods to get to the answers. So they are also present in the collabs that I've shared with you. So you can go through those and just get familiar with the assignment based questions and the videos and how to solve them by hand calculation. So that is all that I would recommend for these new weeks. Okay, and coming to week 8, you will have had converting text into some form of encoding. So primarily you would have seen things like TF, IDF and count vectorizer. So I will recommend to go through those. And when it comes to images, you can think about loading images and then different ways to pre-process it. So you might have change the shape of the image, then work with different channels. And then you would have seen augmentation of images. Okay, so all these things are there in the videos also. So go through them once and practice the assignment once. Okay.
So formula for cosine similarity is the dot product of the vectors divided by the norm of the vectors, right?
Correct. A dot B by norm of A into norm of B. Okay, like cosine similarity is one of the things that were a part of the assignment in week 10. So you should be good with those as well, how to do the calculations on that. You can expect
videos from week 8 onwards will be helpful. Week 8, 9, 10.
Sorry, can you repeat?
Watching videos of later weeks will be helpful in clearing the questions.
Yeah, for week 8, 10 and 12, for sure for these 3 weeks, I would recommend watching the videos and doing the assignments by understanding how the solutions are obtained. Okay. And for completion,
so are there any practice questions?
Yeah, for week 8 and 10, like I said, just take a smaller version, right? So you can go here. You would have seen, you will be seeing the graded assignment. Okay, so you will have seen this one is given to you. So you can, whatever you have as the data set here, you actually just try this out. If you've not done the assignment, I will just say, try this assignment, and that is pretty much all that is needed. And see how the calculations are actually done. So anyway, the code snippet is there as part of the collab that is given to you all. So understand how these things are done, and that should be sufficient.
Solution is present in this assignment.
The solution for week 10, we will be uploading it either today or tomorrow. But the code snippet that is needed for it is covered in the lectures. So in the lecture collabs, you can get it.
So all these collabs are shared in the with us in the supplementary content.
Yeah, in the supplementary content you can see. So this is week 10 collabs. So one of these collabs has the sort of solution code snippet that you need. I think it is in the user collaborative filtering. So just go through the questions and see how to solve them. Week 9 you have k-means, hierarchical, and end-to-end ML. So end-to-end ML is already anyway covered in the other weeks, so you can expect questions from these two topics mainly. So k-means as well as hierarchical. So I would recommend focusing on that. Week 10 we already just discussed, and week 11 no questions on this. Okay. So this is the rough outline of what you have to learn. So week 1, just as an example, I sort of explained by mentioning all the things that are covered and how you can go about it. So these might be your different methods. So going through the different methods, reading their documentation will always help. For the subsequent weeks, know how these things work, go through the documentation. And anyway, you have plenty of previous papers for it. I think there are also those websites where you get those previous papers. You can practice with that also if needed. But for the new weeks, that is the only recommendation. Watch the videos once and solve the assignments by hand, wherever with a smaller set. Okay.
Could you please share this document with us?
Sure, I'll just.
Sir, you not mention week 6.
This is for week 4 to 6 actually.
Okay.
Sir, in that clustering, that hierarchical, there was this simple clustering and distribution based, and so that is not very clear. Distribution and density based and all that.
Okay, so we'll take that up tomorrow. That specific part. But I would also recommend you first go through the live session that was covered for week 9, and if it is still not clear, tomorrow we'll discuss that one.
Okay.
Okay. So here we have week 1 pandas and data frames. Week 2, these are the topics. Weeks 4 to 6, all the models, hyperparameter tuning, regularization, cross validation. Week 7, learn about solving a simple version of each evaluation metric. And week 9 is again k-means and hierarchical that are important. But for weeks 8, 10, and 12, watch the videos once and do a simple assignment, practice with the assignments. So that is my recommendation.
Sir, can you give 2-3 minutes to explain feature union?
Feature engineering.
Feature union, sir.
Sorry, I cannot hear you clearly.
Feature union, she's saying. Feature union.
Okay, feature union. Yeah, just give me 1 second. Okay, I've just shared the document here. Not really containing anything different than what you would have seen. But mostly focus on these weeks, and like I said, there is going to be equal weightage across all weeks. So you can expect questions from every single week, except what is mentioned here. Roughly, the paper can have anywhere between say 20 to 30 questions. It's not really going to be very time consuming as such if you have prepared and are thorough with the ideas. Okay.
So 1.5 hours will be given, right?
Yeah, it is more than sufficient for it actually, provided you have practiced well.
If we go through all assignments and all, then it will be easy, like normal week 1.1, 1.2, like this.
Going through all assignments will definitely help, but I would mostly say focus on the things that I've mentioned today. primarily focus on those, and of course doing those assignments would have always helped you, because those itself are the methods that can come up as questions.
Okay, sir.
Okay. So there's a question on feature union, right? Let me just present my screen. Give me Okay, so let me present my screen. Okay, I hope my screen is visible now.
Sir, before you start this, sir,
Yeah.
can you give us a list of any PYQs for solving the questions on the?
So
I
coming to
mean,
PYQC, yeah,
not much papers are I have seen on MLP. Only.
Is it? I mean, see, because now the setup has changed. Previously, there was quiz 1, quiz 2, and end term. So, given that the syllabus now is weeks 1 to 12, I would recommend you can even practice from quiz 1 and quiz 2 papers. Okay.
Okay.
So overall, MLP should have run for about 2 to 3 years now, right? So you'll easily have about over like 10 to 15 papers at least.
Okay. Including quiz 1 and quiz 2.
Yeah, including quiz 1 and quiz 2. So at the bare minimum, you will have those many papers. You can, for those weeks that are there previously, you can of course always practice using that as well. Okay. So there are these websites that I think have them. If not, also you can collect it from your peers. Okay, coming to feature union, the reason why we use either pipelines or column transformer, or in this case feature union, is when you want to make many changes to one specific data, and we might always make the mistake wherein we might leave out some things, we might not do it in the proper order, and these things help solve that problem. So if you see here, this estimator applies a list of transformer objects in parallel to the input data and then combines the results. Now, for example, you might want to first apply different pre-processing techniques, and then you might want to follow it up with using something like a feature selection method. It would be, say, recursive feature elimination, or you might want to use, say, PCA and so on. Now, using feature union is going to help you apply all those things at once and then give you the final product in the correct format. So it has some similar setup. So one is transformer list. You have to pass in different transformers, and you can also get it as name transformer at the end. We'll look at a simple example to it. Their example is not very great, but here you can see that they have created a feature union object, and they want to apply two things. One is you want to apply PCA, wherein you want to take this one component, but then you also want to apply SVD, and then you want two components out of it. And then once you get the results, you want to combine the two of them. So here, if you see, initially you started off with 3, and then you use fit transform on it, and then now you have the two parameters, one what you get from SVD, another what you get from PCA. Is that okay?
So what's the difference between pipeline and feature union?
You can kind of use both of them for it, but pipeline is primarily used when you want to apply it one after the other in sequence, and feature union is preferred when you want to apply things in parallel and then combine them.
Okay, so in parallel, the result will change.
Yeah, so it depends on how you, what approach you want to go with. So if it is not going to make a difference if you use it in sequence or if you use it in parallel, then it is fine. So with feature union, you can pass in specific features which you want modified also.
Okay.
Okay, so you have that option. So whereas in pipeline, you want to go in order with all these things that you want to apply. So it's just the way you apply these different combination of transformers.
So if pipeline executes in order and some feature is taking a lot of time, that will stop the like halt other process.
It is not necessarily in terms of halting the other process. It's just that it will go in sequence, right? So if you make a mistake, then it will not run at all. So if the first one, if it has an error, it won't run. Otherwise, it will sequentially apply one after the other and give you the final one.
But it could also be like something is taking more time, some feature. That
Yeah,
could
so
be
then it will just, whatever time it takes there, it is going to wait until the end of that, and then itself it is going to go to the next process. So in the case of pipeline, you will not really do any parallel application.
So parallel will be faster, right?
Parallel will be faster, but it depends on whether or not you can use it. Like for all the methods, you will not be able to use, you can do things in parallel. Like for example, maybe I first want to encode my categorical variables and then also scale them using some scaling method. So in that case, you will not be able to do it parallelly, right? You have to do it one after the other.
Exactly.
Okay, so that is where the sequential part comes in. Okay, is this part about feature union okay roughly?
Yes, sir. Yes.
So this is when you want to apply different transformers, and now say on one portion of the data you wanted to use one transformer. And when I say transformer, it could be anything. It could be the imputing, scaling, or some other polynomial transformation, feature selection, and so on. There are all these different methods. They are all going to come under transformers. And you want to use one transformer on the data, and then you also want to use some other transformer on the data. Now, rather than you applying the two transformers and then worrying about how to order it or combine it, feature union takes care of that problem for you. Okay. So yeah, I think that is what they also give here. This combines the transformer objects in parallel to the input data and then concatenates the results for you. Is that okay?
Yes, sir. Yes, sir.
Okay, all right.
Sir, just want to ask one thing.
Yeah.
What week 12 is about, like overview of like week 12,
Yeah,
the
so
time series.
yeah, week 12 is on time series, and that content has been covered in the live session by another instructor. So I would recommend going through those live session itself. There itself, he has covered it. If not, tomorrow, if you have any specific questions, tomorrow he'll be there for a few minutes in the beginning. You can pose the questions to him directly there.
Okay, sir.
Okay. So any other questions regarding either the pattern or the topics and such, broadly? Okay. So that was mainly it from my side. I'm going to close the streaming as well. So as I mentioned, just go through the documentation once and see the important parameters.